How's it going, guys? I got a 12 volt RV water pump, diaphragm pump from Vevor. It's like $60, $70. This is a pretty heavy duty pump. It's like 15 to 17 amps. And I have it rigged up here on an extra well that I have just to see how it would do if it would be able to provide water pressure to a house as compared to something like a half horsepower Gould over here, for example. And so what I've got here is a 2-inch PVC well point. It goes down about 7 feet to hit the clay, and there's water sand down in the bottom like 3 feet of that. And then it adapts to a 1 1/4 inch PVC, 1 1/4 inch check valve, 3/4 inch barb, 3/4 inch braided hose. This is the polyethylene version you get at Lowe's. It's non-BPA. It says that it's okay for potable water. If you go to Home Depot and look at the braided hose, you'll see that it's not okay for potable water, probably because it's just PVC with BPA in it. So it's pretty cool that they have these hoses now, the same exact price. Then you go into a strainer. This is a 5 diaphragm pump, and I have the PSI set at 52. This pump is capable up to 100. It comes set stock at 70, so I'm having it go between like 42 to 52 PSI. I adjusted my bypass setting, which is this one down here. I reduced that, so I got a smooth operation. You know, whether it kicks on at 40 or it kicks on at 50, it doesn't kick and bang because of that bypass setting. So definitely, it's like a mysterious thing. You're supposedly not supposed to touch that, but it can really make a huge difference in how your pump runs. And if you get banging and noise and stuff like that, you just don't want to reduce it to the point where you have the pump not turning off. But you do, if you're going to reduce from 70 psi stock setting, you essentially kind of need to reduce your bypass setting as well. And then it goes into a garden hose here, which is going over to pressurize the main house. And I do have a pressure tank attached to that whole system. So the problem is that this pump does a phenomenal job at all day, every day, until you go into a situation where you have a shower. So after, say, like 20 minutes or so, the pump starts to build enough heat that eventually it'll get hot enough where it has a thermal overload, and it'll shut off for a few seconds and then kick back on. It's 220 watts if you're talking 13 volts at 15 to 17 amps, as opposed to this pump that is 1200 watts with an imperfect power factor. So really it's about 1400 volt amps. And if you're going through an AC inverter, you're talking 1500 watts or so coming out of your batteries to do the job. This one does the same job for 220 watts, 7 times less power usage, because it does actually run about the same amount of time. This thing will fill that tank almost as quick as the Gould's does. So it really is, let's say, 5 times more efficient. That's really impressive. But it's just not quite powerful enough for that sustained use when you're on a situation where you have suction. If you're pulling water out of a cistern, that's a different situation. The pump can fill the tank and shut off for a while in between. So whereas during a shower, when it's dealing with this situation of suction, it just can't catch up enough to actually shut off. So it's maintained something like 42 psi during that shower. Even when it does kick off and on, though, it can still maintain water pressure to finish your shower, but obviously it's just not good for the pump to be running that hot. You put your hand on it and you can really feel the heat. I mean, it's probably, I'm guessing, 130, 140 degrees or something. So even, and also the switch too, you can feel heat in the switch. So the point is, this thing is efficient, but not quite big enough to do the job. Also worth mentioning, I checked the voltage when it was turned off. It was 13.3, and when it's running, it was 12.94. So that's something like 2.7% voltage drop. So it's not a voltage drop issue. It's really just, not big enough to do that job with the problem. I mean, I'm amazed it can handle this kind of suction at all, and it's really probably not designed for that. It's designed to draw water out of a cistern, not to draw water up out of a water table. Anyways, that kind of concludes the experiment. It's a no-go. I'm going to use this on a different system that's drawing rainwater out of a cistern and then pressurizing for a reverse osmosis drinking water system. It's perfect for that. In order to use this as the main, to replace this pump, I need something that's got more power. So I'm going to look into maybe a 24-volt system and give that a shot. But I don't really know of any that have enough overall wattage that could necessarily outperform this. I'm going to have to keep searching and see if I find anything. If you guys have any suggestions, I appreciate it. Any comments, post them up. Criticisms. Thanks for watching.